frying in the cooking process of food is universal. That we all know. This is something very common, and this is practiced all around the world. The process is carried out usually in edible oils such as olive, coconut, soya, sunflower, peanut, palm oil, etc. So just to understand how much of oil that is being used in the world, I have made a table to show you the percentage of oil that is consumed in the world. As you can see, palm oil and soybean oil are the oils that are being most used in the world. 41.31% palm oil and soybean oil 41.28%. If you remember these percentages, you will appreciate why these oils are important and what is the problem in using these oils for frying. And luckily, most of us in Sri Lanka and probably in India use coconut oil. It's not a very high percentage that is being consumed. However, most of us use coconut oil. Let's discuss something about the physical status. Oils and fats are products of glycerol and fatty acids. The chemical structure of these I will come back later in the next slides. And physical state of the oil or of oils depend on the nature of fatty acids, whether the fatty acids in the glyceride molecules are saturated or unsaturated or trans fatty acids. This is actually one of the slides from Fatima, who was with me some months back. I told her that I have taken one of your slides and don't complain that I have stolen from you. I think she is here. What is a fatty acid? Here you see a fatty acid. Fatty acids are long chain aliphatic hydrocarbon ending with a carboxyl group. Now the carboxyl group. This is fat. I mean a carbon chain, and there can be carbon chains of length from 12 to 18 carbon atoms. And all these fatty acids, they are constituents of fats and oils. That's why we call them as fatty acids. And where are they present in lipids and oils? Fatty acids are triglycerides. Triglycerides of glycerol, which is a trihydroxy alcohol. And these are the fatty acids. 3 units of fatty acids with a different chain lengths can react with these ones, forming ester, which is called triglyceride or triacyl glycerol. So, the chemical structure of oils and fats, or chemical composition of oils and fats, are glycerides of this nature, where R1, R2 and R3 can be any carbon chain length coming from the following table. Usually most of the edible oils contain carbon numbers 12 to 18. So here we have lauric acid, myristic, tetradecanoic acid, and hexadecanoic, octadecanoic. All these are straight chain fatty acids without any unsaturation. And mostly edible oils and fats contain carbon-18 fatty acids containing unsaturation. These are the unsaturated C18 oils. Oils with 2 double bonds, they are called linoleic acid. With 1 double bond is called oleic acid. That is C18 octadecanoic acid, decanoic acid. And 2 double bonds linoleic acid and 3 double bonds linolenic acid. So the chemistry what I am going to talk about is about the O2 oxidation reactions and isomerization reactions taking place with these 3 fatty acids. Why these 3 fatty acids? Because when you look at the table, I'm just going to go back later. What I'm trying to say is when you look at the composition of these fatty acids, 18(1), 18(2), 18(3) fatty acids contain almost 45 to 75% in oil. That is the reason why I have selected to discuss the oxidation and isomerization reactions of these oils. Just to give you some introduction, what are saturated and unsaturated fatty acids? Whenever you have a fatty acid without any unsaturation, a double bond, this is called a saturated fatty acid. No double bonds, they are all attached to methylene groups. At the end there is a methyl group, and this is called a saturated fatty acid. When there is a double bond coming in, we call it monounsaturated fatty acid because there is only one double bond. And even in that, there are 2 possible isomers. One is called cis fatty acid and the other one is trans. And that can be easily seen here. When you have a cis fatty acid, the hydrogens are on the same side, and the trans means the hydrogens are on the opposite side. These 2 are different isomers and they have different properties. And the properties come from the way this molecule is bent. When you have a high percentage of this in oil, these molecules are very hard to come close by because they are bulky. Their intermolecular interaction will be less. Therefore, an oil having a high percentage of cis fatty acid will be in liquid form. At the same time, when you heat or treat fatty acids, when they become trans, they are much more linear. They can come very close to each other easily, and they become solid. So the physical nature of edible oils depend on the amount of trans fatty acid also. So whenever you have high percentage of cis fatty acids, the fatty acids are found in liquid form. And you can see I have taken a slide from internet to show how the cis fatty acid is bent, a bent molecule, and this one is almost a straight. So when you have 2 straight molecules, they can come close to each other, and the interaction will be much more higher than when you have 2 cis fatty acids coming close to each other. They are bulky and the force between them are not enough to make them to solidify. So here, these are the fatty acids, and I'm just to give you some idea of why sometimes some fatty acids are called omega-3 and omega-6 and omega-9 fatty acids. The usual sign convention is to start numbering from the carbon of carboxyl group. Here carbon number 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a linoleic acid molecule where the double bond is at position number 9 and number 12. But in the Greek system, we can also start from the other end. And when you number, if the number is ending at, the double bond is starting at number 6, carbon number 6, then this is called omega-6 fatty acid. There should be more than one double bond to name this one as omega-6 fatty acid. So carbon number 6 is omega-6. At the same time, when you have a linoleic acid molecule, so the first double bond is starting at carbon number 3, Therefore, this is called omega-3 fatty acid. And oleic acids are called omega-9. Now, also other fatty acids, we don't need to look at them most. Now, here there is a structure of 18-3 fatty acid, where you could start counting from the normal way. The double bonds are at position number 9, 12, and 15. And there are different ways of denoting or writing this one on paper. 18-3, 3 means 3 double bonds. And the numbers that are here show the positions of the double bond. Position number 9, 12, and 15. And you see a letter here, C, 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 which says the configuration of the carbon double bond is in cis form. Both sides, they are cis. Cis, cis, cis. So 9 cis, 12 cis, and 15 cis will tell you that this is an 18-3 fatty acid with 3 double bonds. They all are in cis configuration. So the important C18 fatty acids in edible oils and fats are oleic acid, linoleic acid, and linolenic acid. Oleic acid having 1 double bond at carbon number 9, linoleic acid having 2 double bonds at carbon number 9 and 12, and then linolenic acid having double bonds at carbon number 9, 12, and 15. See, the shortened form of writing is 9C for oleic acid, because we know this is an 18 carbon atom acid. We don't need to mention the number of carbon atoms. We all know what this one represents. 9C means the configuration at carbon number 9 is cis. So here also 9C, 12C, they are in cis configuration. Why? Because most of the edible oils in natural form, they have only cis fatty acids. The plants produce only cis fatty acids. So where are the trans compounds coming from? They are coming from the physical treatment of the fatty acid, of the edible oils. As I explained, you could see the melting point of the different fatty acids vary. And when we go to stearic acid, carbon number 18 has a melting point of 69.6. And when you introduce a double bond, the melting point reduces drastically to 13.5. When you introduce 2 double bonds, linoleic acid -5, and with 3 double bonds -11. That is why most of the edible oils, except coconut oil, you see them in liquid form because of the presence of high percentage of 18-2 and 18-3 fatty acids. So here is a table showing the different composition of 18-1, 18-2, and 18-3. If you sum them up, for example, coconut oil has 5.4 to 8.1 of 18-1 and 1.0 to 2.1 of 18-2. Only coconut oil has just less than 10% of carbon 18 fatty acids. All the other fatty acids, they have 18-1, 18-2, 18-3, summing up to sometimes 90%. So, considering the isomerization oxidation reactions of these 3 fatty acids will give us some idea what is happening with these oils during frying. That is what we are going to look at now. Fatty acids and trans fatty acids in oils and fats. Thermal degradation. Palmitic, myristic, stearic, oleic, linolenic, and linolenic acids. Unsaturated fatty acids are generally found in cis form. During thermal treatment or hydrogenation, cis-trans isomerization takes place. In addition, oxidation, degradation, polymerization, intracyclization, and bond migration can also take place. I am not going to discuss all these. I am going to discuss only the isomerization and oxidation reactions that are taking place in edible oils. The complex nature of fatty acids involved, identifying the source of the products is difficult. So what is happening when an oil is fried? When oil is fried, it reacts with oxygen and it forms a radical first. The mechanism, it forms a radical first, and this can go into termination or propagate through the propagation step to form a hydroperoxy acid, and then it can cleave into smaller components and form smaller components of aldehydes and hydroxyaldehydes and aldehyde acids. And the next slide shows a depiction of what is happening with the acid during oxidation. So first it reacts with oxygen and forms a radical, and the radical reacts again with oxygen to form another radical, and this can cleave at a certain position and form aldehydes and ketones. At the same time, this can also combine to form dimers, polymers, and so on. So all these are showing pathways of forming different products. We don't need to look at them. We know that these are going to give different products of different nature and different toxicities. Now we can look at the cis-trans isomerization in 18-1 fatty acid. This is carbon number 9. We know that it contains one double bond. At carbon number 9, the construction the configuration is cis. This double bond can move along the carbon chain and form different isomers. In addition to that, the double bond, one of the bonds can open, and then the bond can rotate and form a trans compound. So this is the isomerization reaction going from cis to trans. And during heating, this can take place. Only one isomer that is being formed. And this one shows the different products that are formed during oxidation. And the reaction mechanism I showed that it forms a peroxy radical for hydroperoxide, and this can cleave at different positions, for example X and Y, and when the breakage is taking place at X, it can form several different compounds. This is a aldehyde fatty acid, and this is an aldehyde, and this is an alkane. All these compounds are toxic, and their toxicities are different. This is only at position at X. What happens when it cleaves at position Y? Then they form, the cleavages form different compounds. 6-hydroxyheptanoic acid and 2-undecina. So now we have seen with only one double bond, this has formed several toxic compounds. So when I take the next 18-2 fatty acid, I am not going to give you any mechanism or the pathways. I am just going to mention the products because it's going to be complicated to lay out all the reactions. So now you know that these are, the double bonds are opening and isomerization takes place. At the same time, oxidation takes place to give toxic compounds. What are the products of 18-2 fatty acid? 18-2 fatty acid can form 3 isomers, cis-trans isomers, 9C from 9C, 12C. The 9 can go into trans and the 12C remains, or the 12 can go into trans and 9C remains, or both can go into trans. So there are 3 isomers that can be formed from the linoleic acid. So when you heat, these 3 isomers are formed. And what happens when you heat the oil? There is a shortened form of 18-2 fatty acid. We can explain this one by a radical mechanism. The isomerization takes place. And there is another type of isomerization forming conjugated linoleic acid. This conjugation means when the double bonds come into conjugation, we call them as conjugated linoleic acid. This happens when 18-2 fatty acids are heated. What happens? The radical mechanism shows that the formation of a fatty acid 9T11T is formed first,